All right, let's take a look at volumes by cylindrical shells. So here, set up, do not evaluate this integral. Here we've got functions of x, and we're revolving about the y-axis, but we're doing so with dx. And so the fact that we have dx and we're revolving about the y-axis, that's an indication that we're going to get cylindrical shells. So just to get a approximate visualization of this, let me pull this up here, right? The the function of x, why did that do that again? I don't know. The function of x is going to be this vertical rectangle here, and then the y-axis is going to be this vertical line here, and you piece this together, you get the shell of the cylinder. So here the volume is going to be essentially 2 pi r f of x dx, or maybe better said, 2 pi r h dx. Because sometimes the height is not just f of x, but maybe like some difference between two functions. As it turns out here, y equals ln x is just the function like so. Y equals 0 is the horizontal axis. X equals 8 is over here at 8. And so incidentally, you're between 1 and 8, because 1 is where ln x intersects the x-axis. But now we're revolving around the y-axis. We want to do so with vertical rectangles to do this appropriately. And so, yeah, so what this is going to turn out to be, 2 pi r h dx, where h is the height of our function, and r is just x, because this rectangle is somewhere generically between 1 and 8. It would vary in position depending upon where we drew it, so we would put x as the position on this, and the radius is between x and the vertical axis. Okay, sweet. Right, number 2. Refer to the figure OC, R1 about OC. So we're taking this blue region around the vertical axis. Well, we're defined by y equals 7x cubed. That would be straightforward to work with as a function of x. So we want to imagine our rectangle going vertical here between 7 minus x cubed and 0. Really, our rectangle is exactly of height 7x cubed. And then whenever we revolve around, our radius is going to be exactly x, because that rectangle, wherever we drew it, between 0 and 1 along the x-axis, is going to be wherever it is, namely position x in general. And so we have, what, 2 pi x times 7x cubed dx as the guts of our integral between 0 and 1. Why between 0 and 1? Because we're working with a function of x. We're going to be finding our boundaries along the x-axis. Well, this would be between 0 and 3. Okay, fine, we can see that. But this is looking, if this is a solid revolution, this is looking like 2 pi x times f of x dx, where f of x is x to the 7. Because 2 pi x would be the circumference of our shell, the width of the label whenever you would cut and unravel. And so since 2 pi x is associated with the width of the label, x to the 7th must be associated with the height of the label. And so I'm guessing x to the 7th is coming into play. And what are we revolving around? Well, if it's a function of x, we've got to be revolving around the y-axis in order for us to get cylindrical shells in the game. So by virtue of the fact that we have dx here and cylindrical shells all the way through, you know we're going around the y-axis. But the x to the 7th indicates the appropriate function. Right. Use cylindrical shells, find the volume, given it. Okay, right. We like this first one's going to be real hard to solve for x, so it's already in the form of a function of x. Make this one in the form of a function of x, take the x to the other side. If you have y equals and y equals, set the two equal to one another. When you set the two equal to one another, you solve for the x, you'll find the intersection points. Once you find the intersection points, you figure out which function is on top or bottom in between, and then you're revolving around the y-axis, so your radius here is going to be exactly x wherever that rectangle is located between the intersection points. Your bounds on your integral are going to be the intersection points themselves. And then the guts of your integral, right, would be 2 pi times the radius. The radius is x because we're from the y-axis to wherever our rectangle is. And then it would be one of these minus the other in terms of the function. So it would either be 6 plus 5x minus x squared minus negative x plus 6 or vice versa, depending upon which function is higher. How you know which function is higher, once you know the intersection points in terms of the x coordinates, pick an x coordinates in between. You can compute which function is taller to know which function goes on top whenever you do the subtraction for the height of your cylindrical shell. We're revolving this about the y-axis. So we're going to use our functions of x here, revolve around the y-axis, and we will get a shell integral. So we'll have 2 pi, since we're going around the y-axis, the radius is just x, so it'd be 2 pi x. The height is going to be the difference between the two functions, so 5x minus x squared. Take away x, which I think comes out to be 4x minus x squared. And then, yeah, dx, the thinness of the rectangle, is the thinness of the cylindrical shell. Use the method, so revolve around x equals 2. Now, x equals 2 is a vertical line, and so to use shells and x equals 2, we're going to need a vertical line. We're going to need our rectangle to be up and down, narrow with respect to the x-axis. So we're going to need functions of x within our expression, which actually y equals, that works perfectly. And we're looking all the way over to x equals 1, but then we're revolving around x equals 2. And so be careful when you compute your radius here, because your, let me actually get out the snipping tool for this, because your region goes over to x equals 1, but now right. We're revolving around x equals 2. So be careful here. There is our rectangle, and our radius is going to be here. So the big one is 2, x equals 2. And the little one is x equals x. So the radius here is going to be 2 minus x, big one minus little one, to find that horizontal measure of r. Right, to set up but do not evaluate. Was this the exact one in the class? No, I guess we didn't do this one. Oh, that's because my snip cut that off. Right, so y equals, that's good because that's function of x. We're going dx, that's very good. We're revolving about x equals 12, so similar story. We're going all the way over to x equals 12. I bet the intersection points lie to the left of x equals 12. So I bet whenever we compute our r, the distance from the outside to the x of rotation, it's going to be easiest to do 12 minus wherever our rectangle is, and our rectangle is always going to be at x horizontally. So the little r here should be 12 minus x. Right, if this is revolved around the y-axis, the volume of the resulting solid, no. That's pi r squared. Pi r squared is related to a disk, not a shell. Yeah, revolved around the y-axis. The vertical cross sections perpendicular to the x-axis of the resulting solids are disks. If we're revolved around the x-axis, oh yeah, revolved around the x-axis, you do get disks. Because revolving around the x-axis, our region is touching our axis of rotation. Next, volume of solid about the line x equals minus 2. X equals minus 2 is over here. No, x equals 2 in the y-axis. X equals minus 2 is going to increase the radius. By increasing the radius, we're going to increase the volume of our figure. Take this shape and revolve it around the y-axis, and then take the shape and revolve it around x equals minus 2. Revolve it around x equals minus 2, you have so much more circumference. There's going to be so much more volume in that case. So yeah, there's no way the volumes of those two things are the same. Do we get false all the way across the board here? No, 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 we get true here. And we have false here because that's not the formula for shells, which would be what would be required to take a function of x and revolve it around the y-axis. Okay, sweet. Hey, that's an assignment. Hopefully this is helpful. And if you have questions, just let me know.